Hi, welcome back to this channel. In the previous session, we had discussion over the 17th group. Till we have studied about 15th, 16th and 17th group. Let us move on to the last part of your periodic P block elements. It is nothing but 18th group elements. In a group 18, there are 5 elements are there, important elements. These elements exist in a gaseous state. These gases are called as noble gas because of their fully filled electronic configuration. The element in the group 18, all element shows completely filled orbital. Because of that, these are highly stable elements. Because of their stability and based on the reactivity, these are known as noble gases. All elements are known as noble gases. Okay, let us discuss about the noble gases or element in group 18. Okay, then what are the elements present in group 18? The first element is helium, next neon, argon, krypton, xenon. The last one, radioactive element, is also considered. This one is radon. So these are the elements present in group 18: helium, neon, argon, krypton, xenon, radon. Okay, all these elements shows completely filled orbital or shell. The electronic configuration of these elements are: first one, helium. Based on the atomic number, the helium, the atomic number is 2, therefore it is 1s2. 1s2. Next, what is the common electronic configuration of other? Except helium, the common electronic configuration of noble gas is Ns2 Np6. Okay, common electronic configuration is Ns2 Np6 except helium. Helium shows Ns2 or 1s2 electronic configuration. Next, neon is 10. Because of that, 1s2, 2s2, 2p6. Next, 1s2, 2s2, 2p6, 3s2. Okay, next 3p6. The other electronic configuration of xenon, krypton is and radon. I left to you. It is your work. Okay, just identify or just write the electronic configuration of krypton, xenon and radon. Okay, it is left to you. It is not much important, but I would like to know about your knowledge about the electronic configuration. That before I left it to you. Okay, next, the occurrence of these elements. Occurrence of noble gases. Occurrence of noble gases. Yes, as you know that the noble gases are they present in atmospheric air. The atmospheric air is the source of noble gases or group 18th element. The out of all noble gases, argon is the most abundant element or most abundant gas in atmospheric air. Okay, so therefore this part is very important. Argon is the most abundant element in the noble gases, and so occurrence is from air. How to separate or how to extract or how to obtain particular noble gas from air? By using Ramsay-Riley method. Okay, there are several methods. Two or more important methods are there, but the very important or very familiar method is Ramsay-Riley method. From that, we separate the noble gases individually by changing the temperature. Okay, it is completely depending upon the boiling point of the noble gases. The different gases shows different boiling point. Based on the boiling point, we separate the noble gases. The extraction is possible by based on the principle of the boiling point of the noble gases. Okay, so this is about occurrence. Argon is the most abundant element, and the compounds of the noble gases. In earlier condition, the one element is known in the during the different formation of different compounds. The one element is known. The element is O2 plus platinum F6 minus. Okay, hexafluoroplatinate. So this type of compound is actually exist in the system. Okay, this compound is first observed by Brittle. So after that he was tried to produce the compound from noble gases. During his experiment, he was observe one important thing. The important thing is the ionization enthalpy. You observe that ionization enthalpy of oxygen. The ionization enthalpy of oxygen is around 1170. Based on the ionization enthalpy of oxygen in this compound, he was observe the ionization enthalpy of the noble gases also. At that time, he obtained or he observed one very important thing, that is the ionization enthalpy of the xenon is also very near to this oxygen. Therefore, he tried to produce a compound from xenon, and at the last he was successfully give one compound. The compound is nothing but xenon platinum hexafluoride. This is the first compound obtained from noble gases. Okay, this is the first compound obtained from noble gases. What is the reason of formation of last compound from noble gases? It is completely because of the electronic configuration. A completely filled electronic configuration is observed, and it is all elements are stable, less reactive. Because of less reactivity, you can't observe many compounds from noble gases. Okay, this is about the occurrence and the compounds of noble gases. For your exam point of view, the 2 points are very important. Argon is the most abundant element in Earth. Helium in universe, helium is the most abundant. Next, the first compound of noble gas is nothing but xenon platinum hexafluoride. Okay, so these are the very important concepts for your exam point of view. And for your competitive exam purpose, this compound is also play an important role. Which compound shows similar property with xenon platinum hexafluoride? Oxide platinum hexafluoride or hexafluoroplatinate complex. This is the red color complex, red crystalline complex. This is also crystalline compound. Okay, so this is about occurrence and the compounds of noble gases. Okay, let us discuss about the general properties of noble gases. What are the general properties of noble gases? Occurrence also one of the general property. The atomic radii, ionization enthalpy. So these properties, how it varies in noble gases, or better to call it the atomic property. The atomic properties of noble gases. Atomic properties of noble gases. The first is atomic radii. Atomic radii. When we move down the group, Number of electron increases. Because of increasing the number of electron, the number of shell is increases, volume increases, simultaneously atomic radii increases. Atomic radii increases when we move down the group. Okay, atomic radii increases, move down the group. The same property observed in all the blocks or all the groups also. Next, ionization enthalpy. Ionization enthalpy. Ionization enthalpy. Ionization enthalpy of this group. It is completely depending upon the electronic configuration. All the noble gases shows completely filled electronic configuration. That means all are stable, and removal of electron is difficult. Removal of electron difficult means ionization enthalpy is very high, or there is no ionization enthalpy. Removal of electron is not possible. Because of that, we generally call it as a high ionization enthalpy. Okay, high ionization enthalpy. Next, electronegativity. The next property, electronegativity. What about the electronegativity of these elements? When we observe the compound, these elements, there is no electronegativity. There is no tendency of attract the shared pair of electron. Because of that, there is no compounds from noble gases. Very few compounds are observed. Nowadays, we observe two different types of compounds. They are formed from fluorine and the oxygen. This is because of the high electronegativity of the fluoride and the oxide. Because of that, some compounds are observed: xenon, difluoride, tetrafluoride, hexafluoride, and like that, and xenon oxides. So these compounds are formed because of the more electronegativity of the fluorine and the oxygen. That indicates xenon shows little bit electropositive nature, but other all element does not shows any electronegativity. Xenon and the radon, these are shows electropositive nature. Okay, so there is no electronegativity. Next, electron gain enthalpy. Electron gain enthalpy. What about the electron gain enthalpy of this element? Yes, they shows electron gain enthalpy, but the electron gain enthalpy is more positive. More positive. Electron gain enthalpy of noble gas is more positive. That means there is no affinity towards electron, or they does not shows any tendency of taking the electron. When we add electron, more amount of positive energy, that means energy consumed, energy taken by this noble gases. There is no release of energy. If the energy is releases, then it's negative. The chlorine shows more negative value. Higher electron gain enthalpy. It is very less. More positive means electronegativity is very poor. Okay, less value. More positive is less value of electron gain enthalpy. Okay. This is about the atomic properties of noble gases. Next, compounds of noble gases. Compounds of noble gases. Compounds of noble gases or group 18 element. Compounds of noble gases. The only xenon exhibit they has tendency to form few compounds. Okay, when excess xenon is made to react with the fluorine. Excess xenon made to react with the fluorine around 673 Kelvin. Temperature is very important. Okay, around 673 Kelvin they form xenon difluoride. they form xenon difluoride. When xenon react with fluorine around 873 Kelvin, then they form xenon tetrafluoride, and xenon react with excess of fluorine around 573 Kelvin. Temperature is not much, or higher temperature is not needed for these cases. Then it forms one stable compound. It is xenon hexafluoride. Okay, xenon difluoride, xenon tetrafluoride, it is xenon hexafluoride. So these are the xenon fluoride or fluorine compound. Xenon fluorine compounds. These three are the xenon fluorine compounds. These compounds are stable and they shows hybridization also. Based on the hybridization, these different type of compounds exhibited different types of geometry. Okay, what are the different types of geometry observed in this compound? That part will be discussed in the last session of this video. Okay, next one type of compound is xenon fluoride. What are the properties of xenon fluoride compound? Okay, first compound is xenon fluoride or fluorine compounds. How many xenon fluorine compounds? There are three compounds. One is xenon difluoride, xenon tetrafluoride, xenon hexafluoride. What are the properties of this compound? All this compound shows the common property. They has ability to fluorinate the other. That means they act as a fluorinating agent. These are fluorinating agent. So in case of antimony, okay, when antimony is fluoride is treated with xenon tetrafluoride, okay, xenon tetrafluoride, then xenon fluoride plus minus Sb6 plus minus form. Okay, ionization or ionic compounds are formed that indicates its ability to use a fluorine. You can take tetrafluoride, then it becomes 3. If you take 6 hexafluoride, become 5. Okay, similarly all the xenon fluoride compounds or fluorine compounds behaves like a fluorinating agent. Okay, so this is the very important thing about this compound. Next, the second compound is xenon oxygen. There is one compound, the very important compound, xenon trioxide is exists. Then how to obtain this, or what is the method of preparation of xenon trifluoride? When xenon tetrafluoride is hydrolysis of xenon tetrafluoride gives xenon, it is stable compound or stable gas, noble gas. Next, xenon trioxide, hydrogen fluoride, and oxygen, HF and oxygen. Then how to balance this reaction? Okay, here the number of oxygen is 5. Okay, so 5 is not possible, therefore I multiply 2 here. 3 into 2, it become 6 and 2. Okay, when it becomes 6 plus 2, 8. When I multiply 8 into 2, how many? 16. 16 hydrogen. Okay, yes, 16 hydrogen. Next, how many fluorides? 16 fluorides. See here 4. Therefore, I multiply 4. 4 into 4, 16. 4 xenon. Here 2 xenon. I multiply 2. Is it balanced? Just observe. Number of hydrogen 8 into 2. Number of oxygen 3 into 2, 6. 8 here plus 2 is balanced. Fluorine is balanced. So this is the method of preparation of xenon trioxide from xenon tetrafluoride. This reaction is very important for your exam point of view. Okay. Next, xenon hexafluoride. Hydrolysis of xenon hexafluoride. When xenon hexafluoride is hydrolysis, then it gives xenon trioxide plus hydrogen fluoride. Again, now here only 3, therefore I multiply 2. Okay, here only 1, therefore here is 2 into 3. How much? Sorry, here 3 oxygen, therefore I am directly multiplying the 3. 3 into 2, how many hydrogen? Yes, 6 hydrogen, therefore 6 hydrogen. Okay. The very important thing in this type of reaction is how much quantity of water is taken, double the number of HF is formed. Here 8, here 16, here 3, here 6. Okay, this is a small trick to remember the reaction. Okay, so these two are the very important reaction for your exam point of view. Okay, method of preparation of xenon trioxides. Okay, this is a very important concept. Understand? Okay, next, practice read. Okay, suppose you have any confusion, then practice more and more, and otherwise you buy it. There is no other way to remembering the reaction. Okay, xenon trioxide. Next, last one is xenon oxyfluoride compound. Xenon oxyfluorides. The xenon oxyfluorides are prepared. The preparation method is xenon hexafluorides are subjected to hydrolysis. Then it gives xenon oxyfluorides. Here only one xenon is not completed because there is a formation of HF also take place. HF. Okay, how much HF? Here I am using 1, then it is 2. 2 fluoride, 2, here 6. Therefore, I multiply here. When I multiply here 2, then there is a need of multiplication of 2. Therefore, I am going to try to multiply 2 here. Okay, just balancing by the number of oxygen and hydrogen. Xenon, 1 xenon, 6 fluorides. Here 2, I multiply 4. 2 plus, sorry, here I multiply 2. 6 fluorides, 2 plus 4. How many hydrogen? 4 hydrogen. Therefore, I multiply 2. 2 oxygen, 2 oxygen. Yes, balance. Okay. Here also 2 water, 4 HF. Double the number of hydrogen fluoride. Xenon hexafluorides are, suppose it is hydrolyzed small quantity of water, limited quantity of water. Then they give xenon oxyfluoride, XeOF4 tetrafluoride, here difluoride, and HF. Then balance the reaction. Here 1 I multiply 2. I think it's balanced. 2 hydrogen, 6 fluorides. 4 plus 2, yes, 6. 1 xenon, 1 oxygen. So these two are the very important xenon oxyfluorides. So these are the other type of compounds. So how many types of compounds we observe? There are 3 types of compounds. What are they? Xenon fluorides, xenon oxides, xenon oxyfluorides. This type of compound is possible only because of the more electronegative value of oxygen and fluorine and more reactive. Compared to the xenon is more reactive based on their ionization enthalpy. Ionization enthalpy of xenon is lesser compared to other element in the noble gas or group 18. Okay, therefore these type of compounds are observed. Okay, let us move on to the structure of these compounds. All are fluorinating agent. Please remember, all are fluorinating agent. Okay. Next, structure of these compounds. Hybridization again left to you. Okay, it is not given in your NCERT syllabus, but for your competitive exam purpose, the hybridization of the compound is very important. To work in the last class, I was given the one homework, that is hybridization of interhalogen compound. Now hybridization of these compounds, xenon oxides, xenon fluoride compounds. Next, another one is electronic configuration of argon, krypton, xenon. Okay, radon also. Then structure of compounds of noble gases. And first consider xenon trioxide. Xenon trioxide, based on the hybridization, shape is pyramidal shape. Okay, this is the pyramidal shape, and actual geometry, by considering the noble lone pair of electron on xenon, when we consider lone pair of electron, then geometry is tetrahedral, small distorted. Okay, distorted tetrahedral geometry is observed. Next compound is xenon fluorides. This one is xenon trioxide. And consider here xenon fluorides, xenon difluoride, the first compound. Next, second, xenon difluoride. Xenon at the center and fluoride is actually it's the linear, but when we consider the lone pair of electrons on xenon, then it is trigonal bipyramidal geometry. Xenon tetrafluoride, square planar, again lone pair of electron. Okay, square planar bipyramidal, trigonal bipyramidal, square planar bipyramidal. Next, xenon hexafluoride, a seesaw structure or distorted octahedral. Okay, here you can see this one, xenon. Okay, xenons fluoride in square planar, and because of this fluoride, the lone pair is just distorted or distorted square planar bipyramidal. Okay. Next, what is the hybridization? It is left to you. Okay. Next, fourth one, xenon O2 Yep. Xenon oxide, xenon oxide, F, F. There is a lone pair. Again, we observe the distorted structure. Okay, this is xenon contains lone pair. When you try to give the hybridization, at that time you completely understood the concept of the structure and geometry, because at that time only you can observe the lone pair of electron. How many lone pair of that one is not undergone. The electron is not involved in the hybridization, but the orbital involved in the hybridization. Next one, last one is xenon oxy tetrafluoride. Okay, here xenon, fluoride, oxygen, the lone pair. Again, it's actually this is square planar pyramidal, but because of the lone pair, again square planar bipyramidal geometry. Shape is different, geometry is different. Please review the concentration on that part also. What is the geometry, what is the shape? Okay, next, the last very important part is, again in this part, is the uses of the noble gases. The first one, helium. The helium has a lot of uses. Helium is used in the metallurgical study because of inflammable nature and light gas. It is a light gas, therefore it is used to measure the humidity of weather and all that. It is called metallurgical study. And the next one is next use is in cryogenic, because their light nature and the low boiling point compared to the other, it is used in a cryogenic agent. And based on the dilute nature compared to the oxygen, the helium is used in diving the or scuba divers. They are used helium gases. And next, neon is used in discharge tube and fluorescent bulbs, in electrical bulbs, and in advertising screen, and also used in a botanical garden and other places. And argon is used in electrical bulb. The gas is used to filling in the electrical bulbs and all that. Mixture of neon and argon is also used in bulbs and other krypton and xenon. The compounds of krypton and xenon is used as a fluorinating agent. Okay, so this is about the uses. This completes the complete P block elements. Okay, in the next video we will discuss the new topic. Okay, thank you for watching.